you might be asked on a problem, how much heat is involved in a certain reaction? For example, how much heat is released when 1 mole of benzene, C6H6, is combusted? So you're not given a lot of other information, but there is information in the back of the book. You see, if you know what the reaction is and you can balance them properly, and you can find the heats of formation of your products and reactants in the back of the book, then you can find the heat of that overall reaction. So you go to the back of the book and you say benzene, its heat of formation is 49.04 kilojoules per mole. Oxygen, what is its heat of combustion? You can't even find it in the back of the book, and it's not given to you in the problem. You know what it is, though, right? Oxygen gas. To form it, there are no kilojoules of heat involved, because to form it, you're just getting it from its normal elemental form, O2. There's no change. What about CO2? It's negative 393.5 kilojoules per mole. And water, it's in liquid form, it's negative 187.6 kilojoules per mole. You'll note that its gaseous form is a different heat of formation. This is why we pay attention to the states of matter, because they really do affect the amount of heat released in a certain reaction. So now that we have the heats of formation of all these things, we can plug into the good old equation. Heat of reaction is equal to the summation of the heats of formation of the products minus the summation of the heats of formation of the reactants. So plug in, let's see, 12. 12 heat times the heat of formation of CO2. CO2 is one of our products. So 12 times negative 393.5. And then combine 6 times the heat of formation of water. It's negative 187.6. And then subtract 2 times the heat of formation of benzene. It's 2 times 49.04. And then 15 times the heat of formation of oxygen. That's 0 kilojoules per mole. So now do some algebra, and you'll find that the heat of this overall reaction is negative 5,946 kilojoules per mole. Now, what do we mean by per mole? Actually, what we mean here is per every 2 moles of benzene, or per every 15 moles of oxygen. And so this fact allows us to build some unit conversion factors. You see, we're trying to get from how much heat is released when 1 mole of benzene reacts. So from moles into kilojoules of heat. So we need to build a unit conversion factor between the two. You see, when every 2 moles of C6H12 reacts, 5,946 kilojoules are released. So if you have 1 mole of benzene reacting, then you can convert out of moles and into kilojoules using this unit conversion factor. And you should find that 2,973 kilojoules are released when 1 mole of benzene reacts. Now, you don't need the negative sign here because they're asking just how much heat is released. So you know that you have a negative delta H if heat is released. That's an exothermic reaction. If they were asking what is the heat of the reaction of 1 mole of benzene, then you would need a negative value because they don't specify whether heat is being released or absorbed. Thanks for watching, guys.